the right hand side, and the above side there is a frictional stress, that is a tau. Similarly, here below also we have tau, its direction is from left to right, and the thickness, that is dx. And the height, already I have shown it here, that h is somewhere here. This one is h. So, for our analysis, what we have taken, the stress, this one is a frictional stress. This one is a frictional stress, and the P that is acting here, so the P and sigma x are taken as the stresses. Here P, this one is a compressive one. That is, wherever we have to use, it must be equal to minus P. So, this we have to maintain this one. Another one is that during this one we are considering problem being of plane strain type. As per our assumption. The third stress that is depending upon these two, that sigma x, it is taken as half of sigma x. So, here it is just taken as sigma 2 minus p, means we have already derived the expression for this one, that sigma 2, the third sigma x, that is a sigma x is equal to minus p, sigma 1 is equal to minus p, and sigma 2 sigma 3 is a sigma x we have already taken it here, and one of them sigma x is equal to minus p. So, the third one, the third principal stress, that is sigma 2, that is considered as half of the addition of both these two, because here P is a compressive. So, it is a negative 1. Also, we have to use von Mises criteria. During the von Mises criteria, already we have gone through that one. According to that one, already we have derived that shear yield stress is K, and that is a sigma y by root 3, means whatever the yield strength is there, dividing it with the square root of 3. So, according to this one, the sigma 1 minus sigma 2 whole square plus sigma 2 minus sigma 3 whole square plus sigma 3 minus sigma 1 whole square, that is equal to 6 k square. So, if we put all the values, that sigma x minus half sigma x minus p, this one is a statement for the first term whole square. Similarly, for the second one, that is sigma 2 is equal to half sigma x minus p and minus of minus p means plus p whole square is for the third term, second term. Similarly, for the last one, we can say that minus p is already there and minus sigma x is there. So, whole square of this one, this must be equal to our 6 k square. So, finally, if we solve it, I am solving directly here, that, or we can say that this p plus sigma x, that is equal to twice k. So, this one is an important relation regarding sigma x, whatever be the pressure is applied, and shear yield stress. So, what we have? We had P plus sigma x is equal to twice k, or when we differentiate it, we can say that d sigma x is equal to minus dp. So we have our analysis that if we substitute d sigma x minus p minus dp, just put this one in h d sigma x. Earlier we have this relation is equal to twice tau dx is equal to 0. So we have dp is equal to twice the stress upon whatever be the height is there into dx. So up to now what we have discussed, that we have taken our workpiece in between the two platen or two dies. We have gone for the analysis for the small dx strip. There whatever the shear stress is there, we have considered that one, and the force applied from the upward. So during our analysis we have taken the plane type. We have already told that, means we have discussed that it is a principal plane, but if shear stress is there, we cannot take the principal stress or principal, we cannot say it is a principal plane. But for our analysis, the forces are acting, the force is acting from the top, that is much more higher, and that is why we are considering it a plane type or the above surface as a principal plane. On that basis we did our analysis. So the third one we have considered as sigma x minus p, half of that one. So in this way we have to consider our analysis that during the process we have to consider whatever the total length was taken by us. So here we have to take x is very close to the twice L, first one is here. So considering only the half in our analysis. So analysis part, for half part means from 0 to L. Therefore, our 0 is less than or equal to x and it is less than equal to L. It is up to the center of our strip, because when you observe that our material deforms uniformly from the middle one. So from here what we are observing from this place, here the flow is something like this, and we are considering from here to whatever be the axis there. So our x is varying from here to here, and this one is a, you can say 0 0 0 position. So our analysis is only between the origin and the half of the total length of the raw material. So, again another thing that we have to consider, that is sliding between the workpiece and the dies. Sliding between the workpiece and the dies must take place to allow for of the workpiece. So, the sliding, the metal deform in the form of sliding between the dies is taking place for the